All right, here we are, chapter 6. These are the review questions for the exam coming up. So we start out with standard normal, mean of 0, standard deviation of 1. All right, so first question, we're asked to find the area under the shaded region. All right, so we know we're going to the left. We're starting here at the upper limit of 1.13, going all the way out. I don't want to give you the impression this is stopping at negative 3.39. This is going all the way to infinity. All right, so we are lower level of negative E99. The upper level is 1.13. It's a standard normal. Mean is 0 and standard deviation is 1. So we're looking pretty good here. And this is what happens. 8.8708. Oh, I'm circling the wrong one. Spot on. This will always pretty much happen with standard normals. All right, there won't be any discrepancy when we get to non-standard normals, and like you get some sort of discrepancy, but not a great deal. Number two, same idea. He's asking us for the area that's under the curve. So here's my lower limit to my left, and I'm going all the way out to, I can't go any further. That represents positive infinity. So lower level, there it is, negative 1.82, going all the way out to positive infinity. Mean is still 0, standard deviation is still 1. Second function VAS, normal cumulative, 0.9656. And you see that spot on. We sort of flipped the script here. Before I asked you for the area, and now I'm looking for the z-score. All right. This is labeled 1, but actually it's number 3. He's telling me that the shaded region, all right, from here to out to infinity is 0.0694. But the problem is the area that's associated, all right, the area that's associated with this unknown, this z-score, is from here to the left. All right, the fact that this shaded region is 0.0694, that's great. It allows me to take the whole number 1, subtract 0.0694. The area from here to the left, all right, is 1 minus 0.0694, which is, well, instead of me doing the subtraction and maybe making a mistake, I just said, hey, told the calculator inverse norm. Second function VAS down to inverse norm. I told the calculator, you do the work. You take 1, subtract 0.0694. This is the area in white, which is associated with the z-score that I don't know. And it returned 1.48. All right. Let me see something here. All right, so we got those two. All right, number 7, here again, standard normal. He's talking about this precision instrument company. We've probably seen this in one of the homework assignments. All right, if 7% of the thermometers are rejected because they have readings that are too high, all right, readings that are high are always going to be to the left. Sorry, to the right. All right, too high to the right, bigger numbers. All right, if it was too low, it'd be, it's to the left. So this is the score we're looking for. All right. Now, this is the region here that has temperatures, thermometers whose temperature is too high, 7%. Now, once again, the area that's associated with this unknown Z score that separates the top 7% from the bottom 93%, 100 minus 7 is 93%, expressed as a decimal point 9300. The area that's associated with this unknown value is here to the left. All right, so that's 7%. This area in white here is 93%, 0.9300. Of course, all you need to do is put in 0.93. If you get inverse norm, it's a standard normal. Mean is 0. Standard deviation is still 1. So you're in business. Now look at the crazy answer here, because if you had used 7% instead of 93 to correct, your calculator would have given you this negative. But look where this is. If this is the mean here, this is 0. It's a standard normal. Anything to the right of this is going to be a positive number. So how can this number here be a negative anything? All right, it's positive. But if you had put in 7% because you didn't want to subtract from, you get the idea. Do something silly, and it'll give you that silly answer back. Find the first quartile. Well, here's the mean right here. Mean, median, same thing. It represents the 50th percentile. 50% above, 50% below. Now, the 25th percentile is obviously quartile 1 is P25. It's to the left, all right? If this is 50 right here, 25 is there. So I drew a vertical line, all right? If it represents the 25th percentile, the area, all right, from this line to the left is 25%, 0.2500. Once again, inverse norm. I don't need the zeros, all right? Mean is still 0. Standard deviation is still 1. Notice a negative number. Why? Because if it's a standard normal, that represents the median, which is 0. Anything to the left of that's going to be negative. So it can't very well be this, and it ain't going to be that. Those two numbers are positive. A little kind of common sense goes a long way. Goes a long way. All right, so we flip the script now. We go to a non-standard normal. All right, big deal. So the mean is not 0. Standard deviation is not 1. Everything else stays the same. All right, area to the left, area to the right, area in between. Find a probability that x lies between 19.7 and 25.3. All right, so what I did is I envisioned my mean here being 22. I just made sure that 19.7 was to the left, 25.3 was to the right of what I consider to be the mean right there. All right, so my low level, there it is, 19.7. And there's my upper limit, 25.3. It's a non-standard normal, so he tells me what the mean is, 22. He tells me what the standard deviation is. And we come back with an area of 0.7465. Now, notice a slight discrepancy here, but there's nothing even close to that. And then, how is the area going to be more than 1? I mean, give me a break. All right, so these two answers, B and D, were nowhere near close to 0.7465. We're 12 1,000ths away, but I can live with that because nothing else, neither one of those was even close. And they ain't going to be bigger than 1 area. Greater than 17. What I did, I purposely marked my mean, he told me, right in the middle here, 15.2. So 17 is to the right of that, all right, just to make sure this lines up with the problem. Greater than, well, greater than means I'm getting big. I'm going to my right. How far to my right? All the way to E99. So there's my lower limit. There's my upper limit. He tells me the mean is 15.2. He told me the standard deviation 0.9. Put that in. Normal CDF. All right. And I come back with 0.0228. And this one here is right on the money. Right on the money, which occasionally happens with non-standard normals. All right. Upper and bottom, top and bottom. All right. Scores on the English test. Here we get still a non-standard normal. Mean of 37.6. Standard deviation is 7.6. Find a score that separates the top 59. Top is going to be to my right. Bottom is going to be to my left. Can I make sense? Top 59 is to my right. So bottom is to my left. This is the score that separates the two. What's the area that's associated with this unknown? Is from this vertical line to the left. Well, there it is. Bottom is 41%, 0.4100. Well, there's my area, inverse norm, 0.41. Mean is given to me as 37.6 right here, and standard deviation right there, 35.9. And interesting enough, I like it when it's spot on. Same idea here. We're looking for the value that's accepted. We just kind of didn't like this duplication. First quartile. All right, P25. I made sure I just labeled this my mean in the middle of 4.3. Reason being, if this is the middle here, 4.3, the mean of the median, all right, and this represents the 50th percentile, all right, anything to the left of this, all right, is my quartile 1, all right, P25, P50, Q3, P75 would be somewheres over, if I can draw it here, somewheres out here. All right, so if this value Q1 is to the left of 4.3, well, it can't very well be 4.5, all right? And it's not going to be, I don't think, well, it's hard to say. I don't want to say, but 1.1 looks a little suspicious. Either way, what's the area associated with Q1? It's the area from this vertical line to the left. Q1 is the 25th percentile, 0.2500. Mean of 4.3. He tells me the standard deviation, and it comes out to be 4.1 right here. I know it's going to be 4.5. It's to the left of 4.3, the median. Mean and median, same, one and the same. And what do we got here? All right, central limit. The only difference with central limit is that the standard deviation decreases. How does it decrease? We take the original standard deviation and we divide it by the square root of how many values, the n value. All right. So he tells me the mean of a certain state precipitation is 96, standard deviation of 14. Great. Doing 49 years. All right, that's my end value. All right, so what's the probability that randomly picked years will be less than 98.6? Well, if my mean is 96, that's right here in the middle. 98 is to the left of that. All right, so I know the area from here to there is going to be bigger than 0.500. It's more than half the curve. So, this is my lower limit. I'm going from this value less than, all right? It says less than. Less than means I'm going to my left. Here's my lower limit, negative E99. There's my upper limit. There's my mean of 96. Now, my standard deviation now becomes the original standard deviation, which you told me was 14 divided by the square root of how many, in this case, years I'm talking about, my end value. Here's one where I could have done this in my head and said 14 divided by the square root of 49. See, square root of 49 is 7. 14 divided by 7 would be 2, but I'll have to calculate, do the whole thing. And notice again this answer here, and let it be spot on, which is nice. Kind of nice. Still a non-standard normal. We're working with 23 women. That's my end value. My standard deviation is going to decrease. It's going to be the original standard deviation of 13.1 divided by the square root of how many women, in this case 23. But everything else stays the same. We're looking for the probability the blood pressure falls between 119 and 122. I've marked my mean there just to make it coincide with with all the information. So between is my low 119. There's my upper 119 is my low, upper is 122. There's my my mean is 114.8. Standard deviation is the original standard deviation, 13.1, right here, divided by the square root of my end value, which is 23. Here's one where you couldn't have done it in your head. Well, no, let the calculator do everything. He'll take that number divided by the square root. 0.0579, pretty darn close. In fact, nothing else. A, B, and D weren't even in the ballpark, so we're off by two ten thousandths, which isn't bad at all. Another central limit problem. This time, looking for the probability that if 40 mechanics are randomly selected, there's my end value. The time to fix this transmission is greater than 9.1. So 9.1 is my low. My upper is E99. I just put that in just for sake of clarity. All right, so there's my low. There's my upper. My mean is 8.4. He tells me that. My sigma, my standard deviation, is the original standard deviation right here, 1.8, divided by the square root of n. I'm talking about 40 mechanics. All right. Central limit theorem. All right, the last section, 6.6, continuity correction. You start out by subtracting 5/10 from the low, adding 5/10 to the I, and then figure out which way you're going, left or right. More than 40 answers. All right, so here's my 40. Notice I didn't put the 40 down on this vertical line here. I subtracted, continuity correction says to subtract 5/10 and add 5/10. All right. Now, the question is, I know more than, it means I'm going to my right. Now, the idea is, do I start at 39.5 and go to my right, or 40.5? More than 40 does not include 40, so I can't start here and go to my right because I go right over 40. I got to start at 40.5. All right, more than 40. To the right of, to the right of 40.5. There's 45 to the right of it. Fewer than 93. Well, sorry, 93, fewer than 43. All right, so I put a 43 here. I subtracted 5/10 and I added 5/10. Added 5. Oops, here we go. Added 5/10. Fewer means I'm going to my left. Now the question is, I don't, 43 doesn't exist. All right, there's no whole numbers here. So the idea is I'm going to my left, but do I start at 42.5 or 43.5? If I start at 43.5 and go to my left, I'll go right over 43. Fewer than 43 does not include 43. So if it's not included, I got to start to the left of it, 42.5, and go to my left. And there you see it to the left of 42.5. Continuity correction. Here was one that kind of mirrored what we saw in the PowerPoint. If I went to my calculator, and I put in a low of 99.5, because he's asking me for exactly 100. So subtracting, here's my 100 right here. Subtracting 5/10 and adding 5/10. I want the area in between, but using my calculator, I came up with 0.0687. In actuality, this was a closer answer than this was. Here was one where, in order to get the right answer, I had to do a pencil and paper. I took 100.5, changed it to a z-score. I took 99.5, changed it to a z-score. Went to my table, looked up the area that's associated with both those decimals. I came up with 0.0672 from here all the way to the left. I came up with an area of this from 99.5 all the way to the left. To find the area in between, I subtracted the two. All right, just the way I did it in the PowerPoint. Now, whether you see one like that on a test, well, you'll know if you find your calculator does something and you find two answers that are extremely close together. It may force you to do it pencil and paper, but you've got your z-scores. All right, you got that chart that I gave you the very first day we started talking about chapter 6. So hopefully that's in your notes. Hopefully that's in your notes. We lowered this down a little bit. All right, at least 90 convictions. All right, there's my 90, which doesn't exist down here. I subtract 5/10 and added 5/10. And let's see, at least 90 includes 90. So I'm starting at 89.5 and going to my right. So there's my low bound. Yeah, at least 90 includes 90. So I got to start here. If I started at 90.5, I wouldn't have gone over or included 90. There's my low, there's my upper. Now, with 6.6, you have to calculate your own mean. Mean is n times p. All right, so your n is 100. Probability of someone being convicted, your p-value is 85%, so that's 0.85. Standard deviation is the square root of n times p times q. Well, there's my n, there's my p. My q, I let the calculator take 1 and subtract 0.85, but I could have said 1 minus 0.85. In fact, I think I'm using my calculator. I'm telling you this. You can't see it. I'm using it as 0.15. There's my Q 0.15. There's my P. Notice those two have to add up to 1. But it's the square root of all that. The calculator will take care of all that for you. In fact, it takes care of it so good, it gave you the answer spot on. Calculator. At most 40 includes 40. All right. At most 40. Above 40 is no good. So my low bound here, after subtracting and adding 5/10, and most 40, I knew I was going to my left all the way out to my lower limit of negative E99, and most 40 includes 40, so I had to start here and go to my left. So there's my low bound. There's my upper bound. Mean is n times p. He tells me I got 150 responses. There's my n. My p value is 22% as a decimal 0.22. Sigma is the square root of n times p times q. Notice p and q have to add up to 1. If p is 0.22, q is 1 minus 0.2, 0.22, 9303, pretty darn close, off by 3/10,000ths. All right. I hope that helps. If you're in any kind of confusion, you can always email, obviously.